Hey everyone, welcome to this video. Today we're going to have a look at sketching some examples of trig functions. And the first one we've got is y equals 2 cos x take 1. And we're going to sketch the graph between x values between 0 and 2 pi. Before we do anything else, like any other kind of graph, we want to make a few points and give us some information of how the graph is going to look. To start off with, we want to look for the amplitude. And that's just going to be the number, the multiplier of our trig function. So in this case, it's going to be 2. The next thing we're looking at is the period. And that's going to determine how many times we oscillate within the restricted domain, or how long does one oscillation take, in other words. And that's found by looking at 2 pi on n. And our value for n is basically the multiplier next to x. In this case, it's going to be 1. So we get 2 pi on 1, which is just 2 pi. So what it says is from 0 to 2 pi, we get one full oscillation. That's a sine. This time I've got a cos. So it'll be a full oscillation. This is the same for both sine and cos. So this would be for sine, this is for cos. Another point of interest is the equilibrium position. And that just depends whether we've moved the graph up or down. In this case, this 1 at the end moves it down 1. So we get the same shape, it just we take the equilibrium point, so the equilibrium point would move it down 1. So already we have some good bits of information. We can keep going. We can find how far up and down it oscillates. Okay, if it starts at -1, okay, that's our equilibrium point, and our period is, sorry, our amplitude is 2, so it's going to go down 2 from the equilibrium point. So we start at -1, and we go down 2, which will be a maximum, or sorry, a minimum value of -3. But we can also have, from the equilibrium point, we go up 2. So we get +1. So it oscillates for a range. This is our range between -3 and 1. And another bit of information, we can find our x-intercepts. And that's by finding when y is equal to 0. So 0 equals 2 cos of x take 1. So cos x is going to be a half. And for cos of x equals a half, our value for x is going to be pi on 3. And that's for quadrants 1 and 4. So remember, for cos, it's in quadrant 1, and for quadrant 4, for positive values of a half. So we get pi on 3 as our base function. So we're going to get, for q1, well, it's just going to be pi on 3, but for q4, we have 2 pi take pi on 3, which will be 5 pi on 3. So those are our x-intercepts. From there, we can start to sketch our graph. So there's my x and y. We're starting at 0. We end up at 2 pi. So here's pi, pi on 2, 3 pi on 2. Now, first thing, this equilibrium position just means I've moved down 1. So this is going to be my equilibrium position. I've got an x-intercept at pi on 3, so somewhere over here. Also have another x-intercept at 5 pi on 3, so somewhere over here. And it oscillates between -3 and +1. So here's +1, here's -3. Now for a basic cos graph, looks something like this. So I want that kind of shape. So I'm going to start at +1. I'm going to do half an oscillation and I'm going to be down at the negative or the minimum point, which is at pi. Okay, because I've got half of a rotation. My full rotation was 2 pi, so I'm going to end up back up the top there. And then it's just a matter of connecting the dots. Okay, to look something looks like that. And I can just label a few other points. So I've got my equilibrium, and that's essentially the graph. That's all the information. So as you can see, we use our information to start with to put some points on and connect the graph. So in the next video, we're going to have a look at a sine graph. So stay tuned.